Now we're back and we're looking at the multiplication law. So here it states that if we have two things with the same base, so in the general form we have base x, they have two different powers, m and n, doesn't really matter what they are. If we try and simplify this expression, we do this by adding their exponents. So it says that any two or more same bases multiplied together may be simplified by adding their indices, right? I always tell people, well, if you look at the multiplication sign, turn it sideways, it looks like a plus sign. So that's kind of what we do. So let's look at this case, okay? So we have a to the power of 4, and we know we can write a to the power of 4 as a times a times a times a. Then we have a to the power of 5, and we can write that as a times a times a times a times a, right? And then, so if we do a to the 4 times a to the 5, how do we represent this? Well, that's all that just multiplied together. And we know that if we have a times a, that's a squared. A times a times a is a cubed. So every single time we're just adding on 1. So we have 9 a's, so we're going to get a to the power of 9. So we've done this before, we've just not explicitly talked about the multiplication law. So, example 1, if we look at the following, we have x squared times by x to the power of 4. So first check if the bases are the same. So we have an x here, and we have an x here, so we can continue. Step 2, apply the correct law, or correct laws. So here, we have x to the 2 plus 4, and you do not have to show this step, but it may be helpful for some of you. So we get x to the power of 6. Next, let's look at this one. So we have negative 3 and negative 3, same base. Then, so we can just write down negative 3, and I'm going to write it in brackets because it's applying to that negative value as well. So here we have 2 plus 3, and we get negative 3 to the power of 5. Now if you wanted, you could go ahead and just calculate this, right? But it's not necessary, but we'll go right ahead. So we can calculate this, and we're going to find that it's 243. And since it's an odd power with a negative, we know it's going to pick up that negative. Then simplify this one. Well, what happens when we have a mixture between we have numbers and our letters? Well, let's just write this out. So we have 2 times by 3. We can move them around when it's multiplying, right? And then times by x to the 3 times by x to the 4. So here we have 2 times 3 is 6. And then x, well, we have 3 plus 4 is 7. Okay. So, let's look at simplifying these expressions. So, take a go at them. For the numerical ones, if you'd like to get an actual value out, that is completely fine because that's the most simplified expression as you want, unless it was to ever say, leave this in index form. So, as always, pause the video at this point. Once you're ready, press play and we'll go through the answers. Right, so we have here x to the 2 plus 1, we have x cubed. This one, we have 2 to the 2 plus 3, so we have 2 to the power of 5, which is also 32. Here, we have x to the power of 7 plus 4, which is x to the 11. Next, we have 3 squared plus 5. So we have 3 to the 7. Then here we can represent this as negative 2 to the power of 4. And we also know that's just going to be 16. So it's good to be able to take it from, and put it from normal form and put it in index form and then calculate as well. Here, well, this is a mixture of everything. So, in this sense, well, we'll take a couple different approaches. So first, let's go 2 to the 2 plus 2 to the 1 is 2 to the 3. So then we're timesing by x to the 3 plus 1. So we get 2 to the 3 and then x to the 4. That looks really messy. So let's get rid of that 2 to the 3 and just state that as 8 x to the 4. Because that looks more simplified. So when you can expand your numbers. Here, well, let's just look at our x's. So we're here x to the 2, x to the 3, x to the 2. So here, here we're going to get, that's what I did. We're going to get x to the 2 plus 3 plus 2. times by y to the 1 plus 2. So we'll end up getting x to the 7, y to the 3. Right? So we're just dropping all the multiplication signs. And lastly, we can do 3 times 2 is 6. 6 times 4 is 24. And then we have x to the 2 plus 1 plus 3 plus, well, we're adding on a negative 4. Don't really know what we're doing with this negative 4, but we can still apply the rule to it. It doesn't change. Just because it's a negative 4 here, we can still add a negative. So here we're going to get 24. X to the 2 and 1 is 3. 6 minus 4 is 2.